All right, number 12 is the definition of the definite integral. That's what we affectionately called the long way. Now, just remember there is one omit on this test, so if you cannot bear to do this problem, it can be your omit. But our definition of a definite integral is it is the limit as n approaches infinity of the summation of f of x sub I times the change in x. So I just need to find x sub I and the change in x, right? So here's the formula for both of those. Change in x is going to be b minus a over n. So b was 2 and a was 0. So we're just going to have 2 minus 0 over n. I don't know what n is, so I leave it in my problem. All right, then x sub I is just our a value, so for us that was 0, plus the change in x, we just got that, that was 2 over n times I. So it would just be 0 plus 2 over n times I, or 2i over n. All right, so now we're going to go plug that into the definition. So the definition was the limit as n approaches infinity of the summation from 1 to n of f of x sub I, so here's what we got for x sub I, times the change in x, here's what we got for change in x. Okay, so I'm going to pull that change in x out in front of my entire function. Remember, it's a constant, so we have the right to do that. And then f of 2i over n literally means put 2i over n in the place of x in the function. So I'm going to put 2i over n in the place of x and 2i over n in the place of x. So that would be 2 times 2i over n minus 2i over n squared. So that's what you see down here, 2 times 2i over n minus 2i over n squared. All right, so let's simplify that then. 2 times 2i would be 4i over n. And then 2i squared would be 4i squared over n squared. All right, now I'm going to break that up into two separate integrals, two separate summations. So 4 over n is a constant. Let's pull that out in front. So we've already got the 2 over n. We pull the 4 over n out in front, and the only thing that would leave would be I. Then for the second one, I've already got the 2 over n out in front. I'm going to grab this 4 over n squared and put that out in front, and the only thing I would have left is I squared. All right, so our formula for the summation of I would be happy to give to you for the test as well as the I squared. So the summation for I is n times n plus 1 over 2. And the summation for I squared is n times n plus 1 times 2n plus 1 over 6. All right, so now I want to get my numbers together and I want to get my variables together. So I'm just going to reverse these two, just switch places. And the same thing, I'm just going to switch places with the n cubed and the 6 as well. So if I do that, then over here you can see I've got 8 over 2, which will give us 4, and we've got all our n's together. And then we've got 8 over 6, which would give us 4/3, and we've got all of our n's together. So we could do a little bit of simplifying because n times n is going to give us n squared, and then n times 1 is going to give us n. And then over here, we could go through and say n times 2n is 2n squared, n times 1 is 1n, 1 times 2n is 2n, and 1 times 1 is 1. So that would be 2n squared plus 3n plus 1, and now we're going to multiply that whole thing by n. So that would be 2n cubed plus 3n squared plus n. Okay, so when I come down to the next line, I'm going to take n squared and put it over n squared, and I'm going to take n and put it over n squared. So n squared over n squared and n over n squared. Same thing here. I'm going to do 2n cubed over n cubed, 3n squared over n cubed, and n over n cubed. So 2n cubed over n cubed, 3n squared over n cubed, and n over n cubed. Now let's reduce any of that we can. So n squared over n squared is going to give us 1, and n over n squared is going to give us 1 over n. So that's where the 1 and the 1 over n come from over here. All right. Then we've got minus 4/3. This would simplify to 2. This would be 3 over n, and this would be 1 over n squared. So 2, 3 over n, 1 over n squared. All right, so now we're ready to actually take our limit. So the limit of a constant is that constant. So the limit of 4 is just going to be 4. The limit of 1 is just going to be 1. The limit of a number divided by a variable when you're approaching infinity is always 0. So this is going to be 0. Limit of a constant is that constant 4/3. Limit of a constant is that constant 2. Number over variable is 0. Number over a variable is 0. So that's where we got all these guys right down here. And so that leaves us with 4 minus 8/3, which is a positive 4/3. So that is the value by the definition. The second part of that problem says to find the value by the fundamental theorem of calculus. Now that is our shortcut, but because this is on the calculator page, notice it says that you must show work. So you can't just throw this one into your calculator. You do have to show us how you use the fundamental theorem of calculus to work it out. So fundamental theorem of calculus is just our normal integration. So I've got 2x. I'm going to increase the exponent on that to be 2 and divide by 2. So that'd be 2x squared over 2. And then this one is x squared. So I'm going to increase that exponent by 1. So that would be x to the 3rd over 3. And I haven't plugged in my 0 and 2 yet. So now I'm going to plug those in. Excuse me. So the 2's would drop out to make this a little bit easier to work with. I would have x squared minus 1/3 x cubed. And then I'm going to plug in 2. So that would be 2 squared, which is 4, minus 1/3 times 2 cubed, which is 8. So that would be 4 minus 8/3. And then I'm going to plug in 0, and that would be 0 minus 0. So there's our 4 minus 8/3. Minus 0, and that's going to give us the same 4/3. So this makes us exceptionally thankful for the fundamental theorem of calculus that for the whole rest of the time we get to work it out this way as opposed to having to do the definition. All right, then for number 13 they ask us to take the derivative of the integral. The derivative and the integral are going to drop each other out and just leave me with my function, but the derivative was in terms of x and my value was in terms of x. So when they cancel each other out, they're going to change this t to an x. So that's the only thing I have to be careful of, that I switch my variable. All right, for 14, they give me the acceleration and they ask me to work my way back to the position function. So to do that, I'm going to take the antiderivative. Now, if I take the antiderivative of acceleration, it takes me back to velocity. So I'm going to take the antiderivative of t plus 2. So that would just be t squared divided by 2 plus 2t plus c. That would be my velocity. Now, they told me that the velocity at 0 was equal to 3. So that means that if I put 0 in for each of these t values, the answer that I get is going to be 3. So if I do that, that enables me to solve for c. I'm going to get 0 plus c is equal to 3. So c is equal to 3. So let's take that 3 and put it back up here into our velocity equation, and that would give us t squared over 2 plus 2t plus 3. So that's our velocity equation. All right, if they ask me, as they did on this problem, to go further and go back to the original position function, if velocity is the first derivative, then to go back to the original, I need to do the antiderivative. So if I integrate velocity, I get the position function. So I'm going to take the velocity equation that we just had, and I'm going to integrate it. All right, so I'm going to add 1 to the 2, that'd be 3, and divide by 3. Now there was already a 2 there, so 2 times 3 is where we're getting that 6. Then here we'll increase this by 1, so that would be squared and divide by the same number, and then 3 becomes 3t. Now, I didn't put c here because if I put c here, that means it has to be 3. It is going to be a constant, but it doesn't have to be 3, so I can just use a different variable here. All right, so they told me that in the original position function, when I put 0 in for t, the answer that I get would be -2. So I'm going to go through and I'm going to put 0 in for every one of my t values, and when I do, my answer is going to be -2. So that gives me 0 plus 0 plus 0 plus d is equal to -2, so d equals -2. So let's take that -2 and put it in the place of d. And so that's going to give me t cubed over 6 plus t squared plus 3t minus 2. Now, on this problem, I may give you the acceleration and ask you to just go to velocity. I may give you velocity and just ask you to go to position. Or I may give you acceleration and have you go all the way back to position. All right, then for 15 and 16, we're looking at displacement versus distance. All right, so displacement is just the normal integration. Distance is the absolute value and then the integration. Now, both of those I can do on my calculator because this is the calculator page. So let me remind you of how we do that on our calculator. So grab your graphing calculator if you would please, and I will go grab mine. All right, and so for that problem, we can do the antiderivative on our calculator, well, the definite integral on our calculator, by going to our math menu and going down to 9 function integrate. That's one way to find it. Or the other way is to go to alpha window, and you can see it there as number 4. So either one of those is going to put the blank one on my screen so that I could put in my a and b values, and then over here I can put in my function. Now, if it's absolute value, the place that I find absolute value is again alpha window. That very first thing right there is absolute value. So that's how I get my absolute value in there, and then I could type whatever, my equation happened to be, and then of course over here I'm going to put in the same variable. I'm going to put in x. Okay, so that's how we can do those on our graphing calculator if you have forgotten how to. And giving a decimal approximation is fine, or you could switch it over to a fraction if you preferred, either one. All right, 17 was one we omitted, and then for number 18, we have a quantity raised to the 4th power. I cannot integrate when I've got a quantity raised to a power, so I'm going to need to use u substitution. So I'm going to let 1 minus 3t be my u value. The derivative of 1 minus 3t is -3. And so multiply both sides by dt to get the differential. The differential du is -3 dt. So you can see this guy, 1 minus 3t, is going to become u. That's u to the 4th. And then what that leaves me to get rid of is the 3 dt. I don't have 3 dt. I have a -3 dt. So I have to get rid of that negative. So I'm going to divide both sides by a -1. So I'll get -du is equal to 3 dt. So now I can replace this 3 dt with a -du. Okay, I still don't have a rule for division with integration. So there has to be some way to rewrite that so that I don't have to divide. So I could use a negative exponent to move it up to the numerator. And so now I'm going to do my normal integration. So add 1 to the -4, that'd be -3, and divide by that same number. And we could write that negative divided by negative is positive 1/3 u to the negative 3. Then the last thing we need to do is just back substitute. Just put the 1 minus 3t back in the place of u. If you'd rather move that back down to the denominator, you can do that as well.